What is up, amigos? Today we're looking at the side force of a car that is being overtaken. So if we have one car here and it's traveling along this way, and we have another car creeping up on it, and it's obviously going a little bit faster, so it's gaining on it. And then what happens to the side force of this car, this way or this way? So the relative velocity to begin with is very important because it tells us how quickly this car is moving ahead of this car. But generally speaking, what happens is the flow comes in and then it gets funneled into this section here. And because now we have a fairly small gap and there's air being funneled from both sides actually, this air has to speed up because we have a small area. That's just what has to happen. And if you don't know about mass flow rates and how flow accelerates because of changing area, check out this video here. So anyway, this occurs and this results in a drop in pressure. So this face here, we'll start to see a lower pressure and we start to develop a side force here. And if we have a graph, let's say with the relative distance between the fronts here, where we have this right here is where this vehicle is completely ahead of this vehicle. So the tail of this vehicle is at the front of the nose of this vehicle. And now we have the tail of this vehicle is up here. What happens to the side force is it starts to skyrocket and then it will start to go down and then it will come back to normal. And as I mentioned, the velocity, the relative difference is quite important. So to begin with, we'll get the vehicle being like forced towards this other vehicle. And as this vehicle starts to creep along this way, it will be sort of pushed away. And if we have, let's say, a 1 meter per second relative difference in the velocities, the curve might look a little bit like this. So you can see a few things here. First of all, the peak is later, so this vehicle has to be further up to get this peak. And secondly, it's not as great. I should have really drawn this peak a little bit shallower, but whatever. And then if this is 3 meters per second, then we get this. And let's say we have 10 meters per second now. It will get shooting up really steeply, then come down, and again, even steeper, and then go back up. So we are now getting this low pressure very soon, and then it dissipates quite quickly. In addition to the relative velocities, the distance between these two bodies is also important. So we draw another graph now, where we have the exact same idea, where we have, this is where the nose of this car is at the tail of this car. This is where the tail of this car is now the nose of this car. And we have the difference in lateral distances. So let's say this line here is let's say the vehicles are 1 meter apart. And then let's say we go to 2 meters apart. What will happen is we'll actually follow this line pretty closely, but it'll shoot up and then come back down. So what we have here is the point at which this low pressure and high pressure occur is actually not changing. It's the same kind of distance that the vehicle has to be ahead or behind this other vehicle, but the magnitudes change. They get greater. Actually, this should be, let's say, 0.5 meters. I made a mistake there. So 0.5 meters, so it's reducing in distance between the two, which makes sense because if we reduce the distance, there's more air being funneled through and has to accelerate even more to a greater velocity, which then drops the pressure. And that's why we get this peak is greater on either side. So that is how the side force of a car changes. I should also mention one other thing, the magnitude. So we're looking at about around 0.3 for the side force coefficient, and it might range from 0.1 to 0.5. And so that brings us to the end of this video. So if you like this, make sure to like it. And if you want to see more like this, click the subscribe button. And if you want to learn more like this, check out our course in the link in the description. And also check out a course by JKF, where they go through a bunch of this stuff for motorsports and in really great detail. If you like this stuff that we do, you really love what they do because they go in even more detail and through the flow physics as well as the practical applications. So check that out in the link in the description. And I'll see you soon. Peace out, amigos.